Okay, so would like to welcome everybody. I'm Lucas. Today's talking is about cloud, especially engineering clouds and tools to use to make the use of the cloud solutions better and easier for companies, no matter which segment of business. Pretty much everybody's using cloud today, and that's our main topic. So I started my career very early at 16, and after 15 years, working with different kinds of technologies and clients and environments, working inside data centers, it was some kind of a passion, starting with networking. Then things quite evolved a while, and I really fell into this evolution of virtualizing everything, especially components like compute, storage, and networking. So I was able to work with a bunch of different clients and projects, very exciting ones. In these past 5 years, working only with cloud. And this was in between Brazil, Los Angeles, and now Barcelona for a year. And yeah, some good projects. So today I want to cover some topics like why cloud, why it's growing so fast, why the companies should be in the cloud already, the difference between being a cloud architect and a cloud engineer, and what is exactly cloud engineer and what is the role, and dive into what is cloud native and why the companies should be adopting cloud native technologies. So cloud services, right? The definition of Wikipedia, it's very accurate. And basically, in the history of computers, we faced this paradigm of a clustering pool of resources many times back in the 80s with the mainframes to get more power and so on. But now we are seeing the same movement, but in a macro scale, basically worldwide. And we are seeing like governments using cloud. We got the first 4K transmission from the International Space Station, thanks to the cloud infrastructure. And most of the modern life depends on cloud. So you can imagine if services like Google goes down for a minute, people think that internet crashed or something like that. And the majority of the businesses around the globe are using cloud technology, both to support the local logic of the business and provide to the end customers products as well. So why is growing so fast? You might think is in the last 5 to 10 years, we saw a lot of traditional data centers fading out and more companies adopting cloud. This is because cloud, you can get a lot of advantages, and this enablement via having a common base, or you can call it an API that you can. Basically, the cloud provides you an API. You can pretty much build automations on top of it and consume better and have some resources, schedule resources much more faster in a way that you couldn't before. You can provision a huge amount of workloads in a very small time frame, which automation platforms and infrastructure as code platforms like Terraform, CloudFormation, Heat, and many others. And this creates velocity for today companies and businesses, right? So this also brings up a clean approach to the traditional data center model, where if you want to have some kind of replication, you would have to spend a lot to have a recovery system fast enough to to fail over or to be full HA. And with cloud and provisioning tools and infrastructure as code, you can reach like the sweet spot of having a well-designed and well-drafted recovery strategy that would not cost much, but it will be effective according to the business needs. So the question is why companies should go to the cloud, or why companies are not yet on the cloud. You can see here the evolution in the past. I can say here in this graph, in the last 10 years, when we 10 to 15 years, when we start to use virtualization as the de facto standard for data centers and applications. So you see that an evolution happened, and the end goal of this is what we call cloud today. Back in the days, there was not a term to that, and you can see that you start to increase a lot of cut a lot of complexity by managing the infrastructure. Then you cut the complexity of managing the VMs or virtual systems, and you focus on on the service you want to provide. And with that, you can get more focused on the business logic and the revenue itself. So it's very important for a company to have a cloud strategy in place. Scaling is practically unlimited. You can have your workload auto-scaling from one machine to 1,000 machines in a matter of minutes, depending on your accesses and so on. And you don't have to pay for resources that you're not using. For instance, if you want to build a prototype, you can simply shut down and pay only when you're working on it. So there is the question, where should I focus my cloud solution? Public clouds versus private clouds. We can see that Amazon, as today, is the leader of the cloud segment, with more than 90 services and more than 3,149 features since the foundation in 2006. And for private cloud, especially OpenStack, which is the leader for today's technology on private cloud, you have basically you don't have the same number of features, but you can adapt for your business, because most of the companies that uses private cloud, they use for a specific reason. That would be privacy concerns or legal concerns about storing data, not putting data in a shared environment, and so on. And with that, we move to what is the difference between a cloud architect and a cloud engineer. So an architect, in analogy, would build this draft or this blueprint for you, showing basically what you're asked for, like how it should look like, and nothing else. Like basically very high level, detailed on how it should work, right? So the role of the cloud engineer is to go deeper and study like what's going to be the workload and so on, so you don't get like results like your house collapsing or something like that because the architect did the math and he did it right. So we need a little bit of engineering on that. So cloud engineering is a field of engineering that focuses on cloud services such as software service, platform as a service, and infrastructure as a service. And Gartner defines cloud engineering as the process of designing these systems to leverage the power and economics of cloud resources to solve business problems. Right, so normally architects' scope is to make this blueprint of how the application should work, or how the your workload should behave, and the outcome of this behavior that will translate to your business logic or to your application. And engineers take these blueprints, assess many types of details, and select the tools and components to use, and make sure that everything that the architect design will be in place. In the analogy, architects would design like bridges, warehouses, buildings, but it's up to engineers to assess if the plan have the necessary foundation, robustness, and math in place, so it supports stress when it's being used, right? So cloud engineers, they pretty much look like this. They have a background knowledge, networking, architectures, DevOps, data center operations, especially for private clouds, and hybrid clouds as well, and have knowledge of major cloud platforms and the tooling set that each cloud platform can offer for you. Also, getting deeper into the knowledge field of an engineer, you have to understand the conceptual, logical, and physical architecture, master many technologies, frameworks, and platforms. You have to implement the solution, quality for the services like high availability, disaster recovery, scaling, so on, and security as well, and develop applications for flexible deployment. We are talking about multi-cloud, so one cloud application should be able to run in multiple clouds. This is up to architecture layer, but as engineers, we could put a thought inside and offer like ways to for the architects to abstract this kind of vendor locking and choose wisely like the platforms to run in, and use open source projects It's something very important, and apply agile and lean principles in design and construction. So the benefits for cloud engineering for companies is basically you're gonna promote cloud native tools and mindset inside the company, removing complexity from many areas. That means the company should stop thinking about deploying applications in traditional ways, like and start to think a little bit more in the broad spectrum of what the current technology offers, like containerization and automation as such. And it brings also leverage for patterns of design for workloads using the cloud native tools. And the company will have a professional that understands the end-to-end needs for any workloads on basically any cloud and leveraging on cutting-edge technologies. So this basically summarize what it is the cloud engineer role inside the company. And I would like to talk a little bit about the cloud native movement. That is applications designed especially to be used on cloud and bring the power of the cloud much more, to the great market. So cloud native is approach to design, build, and run applications. CI/CD is very important. Container engine and orchestrators to manage the deployments. Delivery is done via these orchestration platforms. No matter which orchestration you're using, you could be using VMware orchestration, you can be using Docker Swarm, Kubernetes, any kind of orchestration platform. And this all sums up to the terms DevOps, CI/CD, and cloud infrastructure. So this brings us improved speed, scalability, and better cost management. So you don't have to, comparing to a traditional model where you don't have a cloud, instead of having to buy all the equipment, the hardware upfront, you would just simply use cloud and get your costs like better managed. When you don't need the resources, you can simply shut down. So this is basically the ecosystem of cloud native. So the main components you should have in mind when applying the cloud native methodologies. So you may be asking why my application is running fine, why I need that. So creation of cloud native applications involves like modular based applications and multiple microservices that reduce the effort, and you can deliver in small chunks your application instead of having giant systems with everything inside. You can have better overview of what's happening inside the cluster or inside the platform. You can monitor microservices, see if the application go down. Your visibility is way bigger. Deployability is how quickly you can put an application on production. You can basically reduce the footprint of your deploy by having very tiny pieces that forms a ecosystem instead of having a big monolith that when you have to deploy, you would have to deploy all at once and do some kind of cutover or blue-green, etc. Testability, when you're using CD, you want to make sure that the software can be delivered as quick as possible by having a lot of testing in place, especially automated testing. That's very important nowadays. Disposability, if you, for some reason, you want to modify your product, you want to make sure that that module will not cause any pain, like comparing to monolithic systems that you would have to recode or change other parts of the system to have this achieved. And replaceability, if you want to replace products in your ecosystem and deploy in different environments and so on. So a brief comparison between cloud native and traditional ways. So in cloud native, you have OS abstraction. You can predict how much time to deploy an application because you have the automated test, so easy to predict how much time you're going to need to promote this to production, while in traditional, you would not knowing that. So you have the right size capacity. You can scale up or down based on the demand of the system. Automated scaling to have all of this in an automated fashion without having to provision more servers in your data center just to handle a spike in eventual, Black Friday or something that would demand a lot of load in your server. So you have all of this automated. And you have rapid recovery. That means that if one microservice fails, you can easily recover from. It's easy to recover from one single module than an entire system that is running in a monolithic way. So in the traditional way, you're very OS dependent. The application is very tied up with libraries. It's hard to update one single component and so on. You have unpredictable deployment time because you always need to check with someone, like if when you did some change, if this change is not affecting other parts of the systems and so on. You have oversized capacity because you have to estimate for the worst, so for the bigger impact in your infrastructure by demand from customers and clients and the end users. You have manual scaling. That means that you need to configure new OSs or add new processes based on the configurations, and you need to apply these configurations manually. And you have slow recovery. That means that if a component fails in your system, you need to do a failover, and depending on the fail, it can take hours or even days, depending on the type of the failover process that you have in place. So this pictures a little bit what is cloud native versus the legacy way to deploy software. Like, you can see that was not an easy way to do that. I work in several projects that we had legacy software, and it's very much like that. It looks very much like that. And once we migrate to cloud native, it's simpler as releasing a bird or a small module. So about the cloud native tools, this is CNCF is Cloudnative Computing Foundation. They are like the hub for many open source and also not open source applications to make making the cloud life or working with cloud easier. All of these tools, they are providing like capabilities for cloud deployments, and they are basically the core of many applications we are using today, and we don't even know. The most famous one we can see on the picture is Kubernetes. It's the mainstream right now, and it's fully incubated and is the first promoted application, mature application of the CNCF conference foundation. Sorry. You can find more information on the Cloudnative Computing Foundation page. They have this landscape where you can browse through different applications and see what is the value of each one. Going back here, you can see that they have many kinds of segments about containers, network, services, so on. Oops. Sorry. This is the link if anyone want to take notes. And yeah, this was my points of view about Cloudnative. Thank you very much.